probability distribution. This is the definition. A graph, table, or formula that specifies all possible values that a discrete random variable can take along with associated probabilities, that is known as a probability distribution. And this is the example. Suppose it was a fair coin three times. Uh, Let me define a random variable x such that a number of head obtained. Then this is the experiment. X equal to 0, then we 3 times tell. X equal to 1, then HTT, THT, TTH, X equal to 2, then HHT, HTH, THH, X equal to 3, then 3 times head. Okay, first of all, my question is, what is fair coin? Anyone knows about this? What is the meaning of fair coin here? Why we are using the word fair coin? Anyone having the idea about it? Phase, true, Mahek, balanced, probability of head and tail are equal. Yes. Fair coin is one which has one side head and other side tail. No, true. It's in every coin one side head and one side tail, but probability is same. That is known as a fair coin. Otherwise, it is known as a biased coin. Okay. So if we're dosing of fair coin three times, that is our experiment, and here we define an event that the number of heads obtained. This is our event. So whenever x equal to 0 for, then we get 3 times tail. For x equal to 1, that means 1 times head. Then we get this event x equal to 2 and x equal to 3. So what is the probability of all of this? That is distribution x equal to 0. So total number of outcome are 8 here, and for x equal to 0, favorable outcome is 1 by 8. Here it's 3 by 8. Here it's 3 by 8, and it is 1 by 8. And graph of this is known as a probability distribution. And if you do the graph, then we get this kind of structure. Here it is x equal to 0, x equal to 1, x equal to 2, and x equal to 3. Okay. So simple meaning of probability distribution is what? Again, read the definition. Discrete random variable can take along with associated probability. So discrete random variable is what? Here x equal to 0, x equal to 1, x equal to 2, x equal to 3 can take along with associated probability. So with x equal to 0, associated probability is 1 by 8, x equal to 1, associated probability is 3 by 8. Similarly for 2 it's 3 by 8, and for 3 it's 1 by 8. Now a graph, table, or formula that specifies all possible values. Here using a table we can specify all this value, or you can specify the values using a graph, or you can specify a value using a formula. So what is the formula here? If you want to make a formula, then formula is f of x equal to x by 8 for x equal to, sorry, to make a formula x plus 1. Okay, formula is not possible here because it's not a generalized form, because for x equal to 0 it's 0, oh sorry, 1 by 8. For x equal to 1 is 3 by 8, so we can make a formula. But what I want to tell you, that using a graph, table, or formula, if you specify the possible value for a random variable which can associate some probability, then it is known as a probability distribution. So there is a probability distribution here, and this is also probability distribution using a graph. If you can make a formula, Then also you can represent probability distribution using the formula. Okay, is it clear to everyone? Anyone having a doubt? Please ask me. So first of all, what is probability function? Let me read the definition first. Let x be a random variable, then a probability function f of x maps the possible values of x against the respective probabilities of occurrence p of x. That means a function is from x to p of x. Okay, first of all, what is the domain? Domain is x, this is a random variable, and codomain is p of x. That means probability of occurrence of the random variable x. Okay, so function is from x to p of x. Now, if this function is a probability function, then it will satisfy these two conditions. First condition is what? Value of the function at each point. That means f of xi must be is in between 0 to 1. Okay, value of the function at each point must be is in between 0 to 1. And second condition is if you take summation of the values of the function at each point, then it is nothing but 1. That means summation of n I equal to 1 to n f of x I equal to 1, that is known as a probability function. It's very simple. Again, function is from where to where? It is from x to p of x. X is nothing but random variable. P of x is probability of occurrence of p of that random variable. Okay. And if this function satisfies these two conditions, what is the condition? Value of the function at each point must be in between 0 to 1. And second condition is addition of the function at each point is equal to 1. Then it is known as a probability function. Like as we discussed in our last slide, for closing a coin 3 times, then we get this kind of output: x equal to 0, then t, and probability is nothing but 1 by 8. Similarly, for x equal to 1, probability is 3 by 8. For x equal to 2, probability is 3 by 8. And for x equal to 3, probability is 1 by 8 to getting a head. Okay. Now, if you generate a function for this, then uh, what is the value of each point? That is less than 1. Okay, that means first condition is satisfied here. Second condition is what? Addition of each value must be equal to 1. That means 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. So addition is what? 8 by 8, that is equal to 1. So this is known as a probability function. Okay, and we define a variable, sorry, random variable in two ways. Discrete random variable and continuous random variable. Okay. Now, probability distribution associated with discrete random variable, probability distribution associated with discrete random variable, then that function is known as a probability mass function, PMF, and a probability distribution associated with continuous random variable that is known as a probability density function PDF. Okay, so it's very simple chain. First of all, we define a random variable. So we table random variable. Then after, there are two type of random variable: discrete and continuous. Then after, probability distribution. Now for this distribution, if we can generate a function, it is known as a probability function, and depends on the type of random variable. Suppose this function is associated with discrete probability distribution, then it is known as a probability mass function PMF. And if this function is associated with continuous probability distribution, that is known as a PDF, that means probability density function. Okay, now is it clear to everyone? Anyone having a doubt, then please ask me. Otherwise, please write yes or no in your chat box. Is it clear to everyone? Phase. It is for other people. Where is Ishan? Okay, thank you. So this is a probability function, and probability function is called a probability mass function in case of discrete probability distribution, and probability density function in case of continuous probability distribution. And these are the example. This example we already discussed, and next example is for rolling a dice. Okay, now try to understand this example. If we rolling a die, then what is the sample space? Sample space is S equal to 1, 2, 3, 4, 5, 6. These are the possible outcomes. Now, what is the probability for each outcome? That is 1 by 6. Probability for every xi is 1 by 6. Now, if you want to make a function, then the function is what? F of xi. That means function at the put xi can be given as a xi to p of xi, where I equal to 1 to 6. Okay, and what is the value of the function? Function can be given like this: 1 by 6. Value of the function is 1 by 6 every time. Okay, it's a constant function. Now, if you try to verify the condition, so what is the first condition? Value of the probability at each point must be in between 0 to 1. So here for 1 it's 1 by 6, for 2 it's 1 by 6, up to for each value to 6. The value of the probability is 1 by 6, and 1 by 6 is 0.60. It's in between 0 to 1. So first condition is satisfied here. What is second condition? Summation of probability at each point. So what is the summation? Summation is 1 by 6 plus 1 by 6 up to 6 times 1 by 6. That means 6 by 6. So answer is 1 here. That means probability at each, a summation of probability at each point is 1. So both this condition is satisfied here. Therefore, we can say that this function is probability function. Okay. Also, it's associated with discrete probability. Why it is discrete probability distribution? Because these outcomes are countable. Okay. So if you define the random variable here, that is xi, this is a random variable, then this variable is discrete random variable. If it is discrete random variable, then this function is known as a probability mass function, Pn. Okay, let me solve some another example. Take whether f of x equal to x by 6, x equal to 0, 1, 2, 3 is probability mass function or not. So what we have to do here? Anyone? Okay, general example. Ravi, it's a general example. Rolling a dice, using a coin, all are the general example. Okay. Now, can anyone tell me what we have to do here? Check whether this function f of x equal to x by 6, where x equal to 0, 1, 2, 3 is probability mass function or not. Anyone? Aditya?
No, sir.
Sorry? Can you repeat it again?
No, no, I don't.
True. Yes, is it
Yes, sir.
replace the value x? Yes. Check if for the probability summation is 1. So it is probability mass function. Yes, Vidhi, very good. Look at here. What is the question? Check whether the given function is probability mass function or not. Okay. So to become a probability mass function, that means P of f function must it must be a probability function first. Okay. To become a probability mass function, it must be a probability function first. And to become a probability function, it must satisfy two conditions as we discussed earlier. First condition is 0 less than or equal to f of xi less than or equal to 1, and second condition will be summation at each point of the function equal to 1. Okay, so function is already given here, and here you want to take whether it is a probability mass function or not. Okay. So let me check, verify the both this condition. First condition, to verify first condition, first we need to find the value of the function at this point. So values are here. Okay, for is not included. Values are here. For x equal to 0, value of the function is 0. For x equal to 1, It's 1 by 6 for x equal to 2. If we replace 2 here, then it's 1 by 3. For x equal to 3, if we replace 3 here, then it's 1 by 2, that means 3 by 6. Each value is less than 1 and greater than 0. That means it must be is in between 0 to 1. This condition is satisfied here. Now second condition is what? Summation must be equal to 1. So if you take summation of all these value, then answer is 1 here. Therefore we can say that this is a probability mass function. Okay, and it's a probability mass function. Why it is mass function? Because the values of the random variable is countable here. That means it's discrete random variable. Because of its discrete random variable, we can say that this function is a probability mass function. Clear? Is it clear to everyone? Okay. Now next example. Check whether function defined below is a probability mass function or not. Now please everyone calculate this and give me your final answer. It's a probability mass function or not. Yes, it's a probability mass function. Sigma of x is 1 here. Okay. Whatever it is, students, just give me your answer. You audible or not? Just a minute. Okay, now am I audible? So you can see here, it's a probability mass function. If you make addition, the answer is 1. And each of the probability for every value is in between 0 to 1. Therefore, we can say that it's a probability mass function because it satisfies both these conditions. Dependent variable x as follows as following probability distribution for x equal to 0, it's 0.
Sir, आवाज
Sir,
नहीं आ
your
रही आपको?
voice is not audible.
Hello.
Just a minute. Hello, now am I audible?
Yes, sir.
Just a minute. Yes, so a discrete random variable x has following probability distribution. For x equal to 0, it's 0. For x equal to 1, it's k. For x equal to 2, it's 0.2. For 3, 2k. For it's 0.3, and 5, it's 2k. And what is the data we have already? It's the probability distribution. Okay. And variable is what? It's a discrete random variable. Okay. Then find k probability when k x less than 3, probability when x greater than or equal to 3, and probability when x in between 2 and 5. Okay. So anyone having an idea how to find k? How to find k?
Sir, summation of all the f of x equals to 1.
Yes, summation of all the probability. Yes, it's 0.1. Here you can see the solution. Summation of f of x equal to 1. Now 0 plus k plus zero point 0.2 plus 2k plus zero point 0.3 plus 2k. That means 5 times k plus 0.5 equal to 1. That means k equal to 0.1. Okay. Now we want to find the probability whenever x less than 3. That means when x equal to 0, x equal to 1, x equal to 2. That means f of 0 plus f of 1 plus f of 2. If you replace the value of k here, then it's 0. For 1, it's 0.1, and for 2, it's already given 0.2. So answer will be 0.3. For x greater than or equal to 3, greater than or equal to 3 means f of 3 plus f of 4 plus f of 5. That means 0.2 plus 0.3 plus 0.2. Okay, and answer will be 0.7. And in between 2 less than or equal to is less than or equal to 5, then answer will be f of 2, f of 3, f of 4, and f of 5 addition of all of this, that is equal to 0.9. So our key point is what? Addition of all this value is 1 here. Okay, this is the key point. Clear? Next example is from a lot of 10 items, 3 items are defective. A sample of 4 items is chosen randomly. Okay, there is a one lot. In that lot there are total 10 items, and from that 10 items 3 items are defective. Now we are going to choose 4 item randomly. So question is what? If discrete random variable x represent the number of defective items in the sample, then find the probability distribution. Clear? So what is the data given in this example? There are total 10 items here. Defective are 3. Okay. And next is the experiment. What is the experiment? We are make a sample of 4 items by randomly select a selected item. Okay. Now question is what? If discrete random variable x represent the number of defective items in this sample, then find the probability distribution. Find the probability distribution. So first of all, what we need to find here to make a probability distribution? Anyone having an idea? If you want to make a probability distribution, what you need first? First of all, read this question. If you have any doubt in this question, then ask me. Then after we will discuss about the solution. Anyone having a doubt in this question? Please write yes or no. Question is clear to everyone. Please give me a reply. I'm waiting. Okay, we need to find a complex. પાછો 0.1 વાળો એક્ઝામ્પલ ક્યારનો પૂરો થઈ ગયો છે. I repeat it. First of all, what we have, there is a law.
સર મેસેજ સેન્ડ નતો થયો એટલે
Sorry?
મેસેજ
પાછું repeat કરે અવાજ નથી આવતો.
હેલો
શું કહેશ?
મેસેજ સેન્ડ નતો થયો સર એટલા માટે
Okay, okay. Okay, let me repeat the question again. So what is the question? First of all, we have a lot of 10 items. In that 10 items, 3 items are defective. Okay. Now we are going to choose a sample of 4 items randomly. There are total 10 items, and from the 10 items, 3 items are defective. An experiment is what we are going to choose a random sample of 4 items. Okay. Now question is, if we consider random variable x as a discrete random variable and it represents the number of defective items in the sample. Okay. Again I repeat, if we consider a discrete random variable x which represents the number of defective items in the sample, then what is the then find the probability distribution. Okay. So using this data, we need to find a probability distribution here. Okay. So as we discussed earlier, to represent probability distribution, we need to represent a function, and using that function, we represent a graph or table or formula. Okay, like there is a probability distribution here, and to make this probability distribution, we need f of x here. Okay, so to find a probability distribution, we need a function first. Is it clear to everyone? Please write yes or no, so I can move ahead. Okay. Now, if you look at the question. Total number of 10 items and 3 are defective. If 3 are defective, then 7 are working. If 3 items are defective, then 7 items are working. So first we assume the number of defective item in the sample as a x. Okay. Then number of defective item are 3. Therefore, the working items are 7 and total number of items are 10 here. Okay. Now if you select 4 items from this sample, we select 4 items. So there are 5 possibility. 0 are defective and 4 are working. 1 is defective, 3 are working. 2 is defective. Sorry, two are defective, 2 are working. 3 items are defective and 1 items are working. So there are total 4 possibility. Okay. So if x equal to 0, here number of defective items. First of all, we trying to find when 0 number of defective item. There is no any defective item. Okay, this is our experiment. In this experiment, we find a probability of uh, every items are working here. Okay. Now, if you at 3 are defective, favorable outcome upon total number of outcome. Now we are going to select 4 items, 4 from total number of 10 items. Okay. So what is the favorable outcome we want? Favorable outcome is what? We want no defective item. If you want no defective item, then you need to select the items from this 7 item. Okay. So how many choices for a selection? 7 C4. So this will be our favorable outcome. And total number of outcome is what? From total 10 items, we are selecting 4 items. So total number of outcome is 10 C4. Okay. And this will be 35 by 21C. Now, first of all, this is clear to everyone. How I can make a formula? Okay. Now, for one defective item and 3 are working, that means probability of one defective item and 3 working item, that is equal to C73. Why C73 or 7C3? Because we select one item from here and 3 items from here, that means total number of 4 items. So one item from here, that means 3C1, and 3 item from here, that means 7C3, and multiplication of both, that means total selection of 4 items. That will be our favorable outcome for this specific event, when in which we need only one defective item. Upon total number of outcome is what? 10C4. Okay. The answer is what? 105 by C. Now everyone, please give me the value of P probability when x equal to 2, probability when x equal to 3, and probability when x equal to 4 if possible. Okay. Please observe this example. If you have any query, then ask me. If you don't have any query, then please calculate this and give me your final answer. I am waiting here. Okay, 21 by 210. Manthan, it's not point 3. Okay, 3 by 10 will be 30. Not possible. What is for other students? 3 by 10. 3 by 10 by 10 not this. Okay. PO4 is not possible. Yes. Okay, very good. Let me show you the solution. Okay, now for x equal to 2, if you want two defective items from 4, then you need to select 3 from this defective item. That means 3C2 and 7C2. Okay, so answer is 63 by 210 for x equal to 2. For x equal to 3, that means 3C3 into 7C1. Okay, answer will be 1 by 30. Now for x equal to 4, it's not possible. Okay, can anyone give me the justification for this? Why it is not possible? Phase, can you give me the justification? Am I audible? We can't select four defective items from three defective items. Yes, very good. Ravi, 3C0 poetry. What is the meaning of this, Ravi? You can unmute your mic because there are only three defective items. So it's very simple. We cannot select four defective items from three defective items. It's very simple. So these are the probability for zero defective item, one defective item, two and three. Now what we want? We want probability distribution for this. Okay. So first of all, uh, if you observe this, then every value is in between 0 to 1, and second one is addition is 1 here. Okay. So every value is in between 0 to 1 and addition is 1 here. Therefore, we can say that the given function is probability mass function, and this is the probability distribution for this specific function. Okay. Only you have to generate a table or graph that is known as a probability distribution. Is it clear to everyone? Anyone having a doubt? Okay, thank you. Now next is probability density function. So as we discussed, if probability distribution is associated with discrete random variable, if probability distribution is associated with discrete random variable, then it is known as a probability mass function. Now similarly, if probability distribution is associated with continuous random variable, then it is known as a probability density function. Okay, so what is the definition? Let x be a continuous random variable, then function f of x of random variable x is called probability density function if it will satisfy these two conditions. Now, if you compare PMF and PMS, sorry, PDF, then it is easy to remember. PMF and PDF. So first of all, in PMF, we are considering x if it is discrete random variable, and in PDF, that means probability density function, x as a continuous random variable RB. Okay, now generate a function f from x to px. If it satisfies these two conditions, first condition, the value of the function must be in between 0 to 1, and second one, summation of the function at each point equal to 1. That is known as a probability mass function Pm. Now in probability density function, what is the change here? In place of discrete random variable, here we are considering continuous random variable. Function is same, x to px. Now condition is what? In probability mass function, the value of function must be in between 0 to 1. Whenever in PDF, the value must be greater than or equal to 0, where x belongs to minus infinity to plus infinity, open interval. Second one is integration from minus infinity to infinity f of x dx equal to, okay. So when its probability distribution function, sorry, probability density function. Condition is the function value of the function greater than or equal to 0, and integration of the function in the interval minus infinity to plus infinity must be equal to 1. That is known as a probability density function. Also, this f of x dx, f of x dx is called probability differential. Is called probability differential. Okay? And if you want to, okay, now this value is for minus infinity to infinity. Now suppose in question uh, it will be asked that find the probability of the function in between a to b. Why in between a to b? As we discussed that in discrete random variable, that is a countable number, and in continuous random variable there are interval, okay, finite or infinite. So in uh, PMF, it will be asked to find the probability at some specific number xi. Whenever in PDF, it will be asked to find the probability in some specific interval. Okay, this is the main difference between both of them. And from this you can discriminate both of them. That in PMF, it will be asked to find the probability at some specific number. Whenever in PDF, it will be asked to find the probability at some specific interval. Okay, so if you want, now question is to find the probability of the x in between 1 to 2. So simple formula is what? Integration 1 to 2 f of x dx. And in general, for a to b, integration from a to b f of x dx. Okay, so this is the definition of probability density function. Okay, anyone having a doubt in this? Let's read the definition first. If any doubt, then ask me. Take 1 or 2 minutes. Is it clear to everyone? Please write yes or no. Okay, thank you. So now example related to this probability density function. Okay. One another definition, important definition is cumulative distribution function, CDF. Okay. So what is CDF? So again, we are make two types of CDF. First one is for discrete random variable. Second one is for continuous random variable. Okay, for discrete random variable, what is the function? It's probability mass function. For continuous random variable, what is the function? Probability density function. Okay, now cumulative distribution function. So what is the definition? Is the definition? Let x be a discrete random variable which takes the value x1, x2, x3 such that x1 less than x2, less than x3, less than up to so on. Then the cumulative distribution function f of x is defined like this: f of xn equal to p, where random variable less than or equal to xn equal to summation from I equal to 1 to n p of xi. That means p of x1 plus x2 plus up to p of xn. So if you want to find p of x2, okay, first of all let me explain this. So in discrete random variable, CDF, how to define CDF? CDF is cumulative distribution function. So first we consider x as a discrete random variable. Okay, here we consider x as a discrete random variable. And if you want to define CDF for continuous random variable, then you need to consider x as a continuous random variable. Okay, start the definition with defining the variable x. Either it is discrete or it is continuous. If it is discrete, then it is CDF for discrete random variable. If it is continuous, then it is CDF for continuous random variable. So x be a discrete random variable which takes the value x1, x2, x3 such that, okay, now the random variable x following this condition. What is the condition here? X1 is less than x2 is less than x3 up to less than xn. Okay, so first we define random variable x, which is discrete random variable, and it follows this condition: x1 less than x2 less than x3 up to so. Then the cumulative distributive function is defined like this: p of x less than or equal to xn. P where random variable x less than or equal to xn equal to summation from I equal to 1 to n p of xi. That means p of x1 plus p of x2 plus up to p of xn. So if you want to find x3, then what is the formula? P of x1 plus p of x2 plus p of x3. And condition is what? X1 less than x2 less than x3, where x must be discrete random variable. Okay. Now if you want to find x4, f of x4, then p of x1 plus p of x2 plus p of x3 plus p of x4. And condition is x1 less than x2 less than x3 less than x4. So this is a very much simple function, probability, sorry, cumulative distribution function. Now there are some property. First property, f of xn equal to p of x1 plus p of x2 plus up to p of xn, as we discussed it here. Okay. Second property is what? Addition of probability at each point is 1. So this is the condition of probability mass function also. Next condition is, next property is, value of the function at each point must be in between 0 to 1. So again, this is the property of condition of probability mass function also. And probability of x, where x is in between a to b, is equal to f of b minus f of a. So this is the different but most time property. Probability of any variable x, where x is in between a and b, is equal to f of b minus f of a. Okay, so first property, if you want to find a value of the function at any point, then just you have to just make addition of probability of x1, x2 up to xn if we want to find the value of the function at xn. If you want to find the value of x5, then make addition of x1, x2, x3, x4 and x5. Second property is addition must be equal to 1. Third property, value of the function at each point must be in between 0 to 1. And third property, probability of x, where x is in between a to b, equal to f of b minus f of b. So there is a definition of cumulative distribution function CDF for discrete random variable. Now, what is for continuous random variable? So first of all, here we define x as a continuous random variable. Then cumulative distribution function f of x is defined as f of x equal to t for any random variable x which is less than or equal to x equal to minus infinity to c x integration from minus infinity to x f of t dt. Okay. Now, if you observe here, then whenever we are discussing on discrete random variable, we consider summation, and when we discuss some continuous random variable, we are considering integration. Okay. So this is the key point to remember this. If you discuss about discrete random variable, then consider summation, and for continuous random variable, then consider integration. Why integration? Because continuous random variable, uh, we have to define a random variable on finite or infinite interval. Okay, and for interval, we are considering here integration. Now, these are the property. First property, f of minus infinity. If you replace minus infinity in this formula, if you replace minus infinity in place of x, and then we get minus infinity to infinity f of t dt. Now both the limits are same, therefore answer will be C. For infinity, minus infinity to infinity, f of t dt, answer equal to 1. So these are the two property. You have to remember this. Third property is similar to CDF for discrete random variable, that is 0 less than or equal to f of x less than or equal to, where x is in between minus infinity to infinity. Now for property, again same uh, for the definition. Probability of, here it is, probability of a less than or equal to x less than or equal to b equal to of b minus f of a. So there is the CDF, that means cumulative distribution function for continuous random. Please read this definition. Okay, try to understand it. If you have any doubt, then ask. I will give you 5 minutes. Anyone having a doubt now, then please ask me. Okay, then please repeat. Okay, any doubt? First property of CDF, there is a range infinite to infinite. Okay, second one, continuous random variable. Okay, Chinal. Anyone else? Ask me if anyone having a doubt. And if it is clear, then we can move ahead. Please write yes or no. Okay. It is clear to everyone. Okay, very good. But these are very much important definition for this unit. Cumulative distribution function and cumulative for discrete random variable and for continuous random variable. Please keep it in your mind. Now next is example. Check whether the following function f of x is a probability density function or not. Now in previous example, we checked that given function is probability mass function or not. And to check it, we verifying the two condition. First condition is the value of function at every point must be in between 0 to 1, and second one is addition of the function at each point is equal to 1. Now to verify probability density function, what is the condition? Let me just show you. Yes, these are the conditions. First of all, the value of the function must be greater than or equal to 0, and second condition is integration from minus infinity to infinity function f of x dx equal to 1. So these are the two conditions to check whether the given function is PDF or not. Okay. Now here you want to verify it, and next question is if so, then find the probability that the variable having this density falls in the interval 1 to 2. Okay, so first we are trying to verify this. So what is the function here? Function is e raised to minus x when x greater than or equal to 0, and value of the function is 0 when x equal to 0. Okay, so e raised to minus x exponential function is always greater than or equal to 0, and 0 that means equal to 0. So value of the function is greater than 0 in given interval. Okay, so first condition is verified here. Second condition is what? Second condition is minus infinity to infinity e raised to minus x f of x dx, that means sorry, yes, f of x dx. So here we have to divide this interval into two parts. First interval is what? Whenever x less than 0, that means minus infinity to 0, value of the function is 0, and for x greater than or equal to 0, that means 0 to infinity e raised to minus x dx. So integration of 0 is 0 here, and e raised to minus x by minus 1, 0 to infinity minus 1 as it is, e raised to minus infinity minus e raised to 0. E raised to minus infinity means 1 by e raised to infinity, that will be 0. So minus 1, 0 minus e raised to 0 is 1 here. So answer is 1. Okay. So both this condition is satisfies here. First condition, value of the function must be greater than or equal to 0 in the interval minus infinity to infinity. And second condition is integration from minus infinity to infinity f of x dx must be equal to 1. So both these conditions are satisfied. That's it. Therefore, we can say that this function f of x is known as a probability density function. Clear? Now, second question is what? If so, then find the probability that the variable having this density falls in the interval 1 to 2. So if you want to find the value of the function is in between 1 to 2, then you have to put the replace the value of the interval 1 and 2. Let me show you the solution. First of all, these are the conditions which we verify also. F of x greater than or equal to 0 and integration is pointing. Therefore, it's a probability density function. And next, now look at here. If you want to find probability in between 1 to 2, so what is the in general formula? A less than or equal to x less than or equal to b, it's equal to a to b f of x dx. Okay, and in place of a and b, here we have 1 and 2. So 1 to 2 f of x dx. If you replace this value in this interval, then it's nothing but 0.23. So this is the example and solution. Anyone having a doubt in this? Is it clear to everyone? Please write yes or no. Okay. Now